Bismillahirrahmanirrahim. Let's see today the page number 85 of VR's physiology, and we are doing a series. So जो important चीज़ें हैं MCQ's point of view से वो देख लेते हैं. सबसे पहले what is stroke volume? Stroke volume is the volume ejected from the ventricle on each beat. हर बीट के साथ, हर हार्ट बीट के साथ हमारे पास वेंट्रिकल्स में से जो वॉल्यूम इजेक्ट होगा दैट विल बी कॉल्ड एज स्ट्रोक वॉल्यूम. How the stroke volume is expressed? Stroke volume is expressed by the following equation. Stroke volume is equal to end-diastolic volume minus end-systolic volume. This formula is very important. Okay, end-diastolic volume में से end-systolic volume minus कर देंगे तो हमारे पास क्या मिलेगा? Stroke volume. Cardiac output is expressed by the following equation. Cardiac output is equal to stroke volume into heart rate. Okay, this formula is also very important from the from MCQ point of view. And then third is ejection fraction. Ejection fraction is the fraction of end-diastolic volume ejected in each stroke volume. Okay, stroke volume was the volume ejected from the ventricle with each beat. Okay, while what is ejection fraction? Ejection fraction is from the point of view of end-diastolic volume. Okay, so ejection fraction is the fraction of end-diastolic volume ejected in each stroke volume. Is related to contractility. It is normally 0.55 or 55%. It is an MCQ. Is expressed by the following equation. Ejection fraction is equal to stroke volume into stroke volume divided by end-diastolic volume. This formula is also very important. What is ejection fraction? Ejection fraction is equal to stroke volume divided by end-diastolic volume. See the three formulas. Stroke volume is equal to end-diastolic volume minus end-systolic volume. What is cardiac output? Cardiac output is equal to stroke volume into heart rate. And what is ejection fraction? Ejection fraction is equal to stroke volume divided by end-diastolic volume. What is ejection fraction? Ejection fraction is stroke volume divided by end-diastolic volume. These three formulas are very important. What is stroke volume? Stroke volume is the work heart performs on each beat. Okay, stroke work. Sorry, this is stroke work. What is stroke work? Stroke work is the work heart performs on each beat. Is equal to pressure into volume. For left ventricle, pressure is aortic pressure and volume is stroke volume. Okay, is expressed by the following equation. What is stroke volume? Stroke volume is equal to aortic pressure into stroke volume. This formula is also important to remember. Fatty acids are the primary source of energy for stroke work. Okay, so it's an important MCQs too. Okay, cardiac oxygen consumption. Cardiac oxygen consumption is directly related to the amount of tension developed by the ventricles. The more the tension developed by the ventricles, the more the amount of oxygen consumption is increased by. How cardiac oxygen consumption is increased? It is increased by increased afterload, mean increase aortic pressure. जितना ज़्यादा हार्ट कंट्रैक्ट करेगा उतना ज़्यादा उसके ऊपर आफ्टर लोड होगा, तो हमारे पास कार्डियक ऑक्सीजन कंजम्पशन इंक्रीज कर सकेगी. इज इंक्रीज बाय द इंक्रीज साइज ऑफ हार्ट का साइज इंक्रीज कर जाएगा. जाहिर बात है उसको ज़्यादा कंट्रैक्टिलिटी फोर्स रिक्वायर्ड होगी तो ज़्यादा ऑक्सीजन कंजम्पशन होगी. इज इंक्रीज बाय द इंक्रीज साइज ऑफ हार्ट प्लस लास्ट इट्स एट द टेंशन इज प्रोपोर्शनल टू द radius of a sphere. Okay, so it's an important MCQs too. कार्डियक ऑक्सीजन कंजप्शन पे कौन सा लॉ अप्लाई होता है? लेप्लास लॉ. जो हमारे पास ज़्यादातर कुछ MCQs जो होते हैं वो लॉज से रिलेटेड होते हैं कि इसमें कौन सा लॉ लगता है या ये किस लॉ पे काम करते हैं. कार्डियक ऑक्सीजन कंजप्शन इज इंक्रीज्ड बाय इंक्रीज्ड कंट्रैक्टिलिटी. मोर the positive inotropic agents will lead to increased oxygen consumption too, because they increase the contractility of heart. And when the heart rate will be increased, there will be also more oxygen consumption. Measurement of cardiac output by Frick's principle. So we are going to do cardiac output measurement. The Frick's principle for measuring cardiac output is expressed by the following equation. This equation is important too. Cardiac output is equal to oxygen consumption divided by oxygen in pulmonary vein minus ऑक्सीजन इन पल्मोनरी आर्टरी। कार्डिक आउटपुट में हमने क्या करना है, पहले ऊपर ऑक्सीजन कंजप्शन रखेंगे, नीचे ऑक्सीजन in pulmonary vein minus oxygen in pulmonary artery. Why the pulmonary vein has placed before? Because pulmonary vein has more oxygen. It carries the oxygenated blood from lungs to heart. The equation is solved as follow. The oxygen consumption for the whole body is measured. Okay, this one. Oxygen consumption for the whole body is measured. Pulmonary vein oxygen is measured in systemic arterial blood. Pulmonary artery oxygen is measured in systemic mixed venous blood. Okay, पल्मोनरी वेन की जो ऑक्सीजन मेजरमेंट है वो कहाँ से करेंगे, सिस्टेमिक आर्टरी ब्लड से, जबकि पल्मोनरी आर्टरी ऑक्सीजन मेजरमेंट हमने कहाँ से करनी है, सिस्टेमिक मिक्स्ड वेनस ब्लड से. ओके, सो एग्जाम्पल वी विल सी इट लेटर ऑन.